and welcome back to my channel. This is Java with Ali and I am Ali. So welcome to those who know already, and for those that don't, you're welcome. Please like, share and subscribe so I know to make more videos. Today we are going to talk about queues. So let's get to it. A queue we use in where I'm from, Irish English, to describe like a queue in the shop. I think in US English it's called a line, so you get in line, but a queue works in a similar fashion, except this data structure is first in, first out. So imagine, let's set the scene, imagine queuing for concert tickets, which people don't do anymore, but pretend. Let's queue for a concert ticket. It's only going to be paper based. You have to go to the shop. You queue and queue and queue. Some people used to queue overnight. And then you get towards the top of the queue and you give up, and that's your first one, first in, first out, and that's exactly how it works. You join at the very end, you go up, and then you leave when you get impatient. The same with different applications work in the same manner. So in a computer CPU for processes, it also works in a similar fashion. So with a computer, CPU can service only one application at a time. Each application requires processor time that can be placed in a queue. And then the application at the front is the next to receive the service, so that goes ahead. And each application gradually advances to the front of the application before it receives the service. So a queue node then are removed only from the head or the top of the queue. And inserted only at the back. So for this reason, it's called a first in, first out. Now, because I'm using Irish English, I'm going to say queue and unqueue. So queue to start, like that's a verb to queue. And so let's say the same happens with print spooling. Remember that if you work in an office or if you're in a university where you have to print stuff, which people don't print stuff anymore, except for maybe in Germany. There's a lot of paperwork here. So I used to work in a paperless office, and I print a lot of stuff here. But anyway, we used to share a printer, let's say a network printer, and you'd see the print job going to, when you look at the status of your print status, you could see the print job going to the top of the queue, and sometimes it would support what's called print spooling. So you could see it says the status says print spooling. So that's maybe if a single printer has multiple people using it, and then it uses a spooler, and you get messages and stuff like that until the job completes. The other thing is using information packets. These are just uses of queues. Information packets on the network. So if you're in technology for a while and you've worked with networks before, then you know the computer program Etherreel, which is now known as Wireshark. I haven't used it in a really long time, but basically it's like a network sniffer. You can look up very easily network sniffers and see the packets that are in the queues. If you can also do this like with programs like Skype, that used to be my project in college. You can use this and you can see the weight in the queues and the computer networks, and you can see the routing node routes one packet at a time, so additional packets then are queued again until the router then can reroute them. Another thing would be a file server. If you have a file server and a computer network handles the file access from many clients throughout a network, then the server has limited capacity to service requests from the clients. When the capacity is exceeded, then the client has to wait in the queue. So there are your examples of queues. So there's plenty different types. So today we're going to look at the program. Then we're still using list. It's up on my GitHub. And we are also using our 4 different methods similar to stack last week. These are all linked videos. So linked list comes first, then stack, then queue. So here we have queue, and it uses the list class as well to the insert at back. So you come insert it at the back and then you remove it from the front. You check if it's empty and you print it. So similar to most of the programs, the only difference with this data structure is that you insert at the back and you remove from the front. So this is our first in, first out, our FIFO data structure, which is different to our stack because our stack is our last in, first out. So here then we have queue test, which just it adds to the queue. So I decided to call the method queue because that's a verb in my that's a verb in Irish English, to queue. So here we have insert at back. So when we call the method queue, it means we're inserting a new item at the back. And in this case, I have decided to call them people. So person 1 is going to be number 1, 2, 3, 4, 5, 6. So we have 6 people that are in a queue. And to remove the people, then it will be the person at the top. So 1 goes, then 2, then 3, then 4, then 5, then 6. And we're using the same Boolean continue loop while queue unqueue to unqueue is a verb. And queue, then we just use the print, and again with our stack trace. So we're going to see our no such element exception appear on the screen once it's done. And within the data package, I actually have multiple main threads, which is a little bit messy to do, but you can do it, and you can have multiple main classes using public static void main, but it's only one entry point program. So you can set it with here. This is just a side note. You can set what one is going to run. If you just wanted to keep it as one package, just top tip. Or if it's a huge program and you want to test different entry ways of settings and stuff like that, anyway, we'll come to another video with that, I think. So the queue is now 1, 2, 3, 4, 5. I didn't print 6 actually. So now we have 1 unqueuing, 2 unqueuing, 3, 4, 5, and 6 unqueuing. And again, we have queue is empty. Empty being null is going to be our last element. Node connected to the next one is going to be noted as null. I'm going to just print this and run it again so it's more clear and more precise. But I think you know at this stage, because we've done the other data structures so far. So you can see that it goes 1, 2, 3, 4, 5, 6 on the screen. 1 unqueuing, 2 because it's from the top. And that's it for today. So this is again up on my GitHub, and thank you so much for watching. Please like, share and subscribe so I know to make more. And in the next video we are going to have another look at more data structures. Let me see what's on my list. It is going to be trees, I think is going to be next. Yeah, we're going to go for trees next. So I'll see you next week, and thank you so much for watching. And again, thank you to all the subscribers so far. So far, so good. Thanks. Bye.